Hello and welcome to the Oxford MAT Livestream. I'm James Munro and today we're going to talk about the MAT 2021 paper. Hello to people joining us in Slido chat. Hi to Zach, Anonymous, Pen, George is here as well. Let me just set that to, there we go, most recent. And Flora's here as well, helping out with chat. It's great to see all of you here with us. Yes, so today we're going to talk about the MAT questions. We had a stream last week, like the day after the MAT, where I didn't want to talk about the MAT questions because it was still so fresh. But today the plan is that we're going to try and talk about some of those questions. We've put a video out that's 10 minutes long and runs through all the solutions. The video is quite stressful to watch, also quite stressful to make. That 10-minute video has got stuff in. It's got, I guess, all the solutions in, but on this live stream I thought we'd talk about whichever questions people want to talk about a little bit, tell some of the stories that are in the questions, work out what they're about, discuss things like that to, talk about the maths in here. Top comment so far, why was it so much harder this year? We've marked some of them so far. I think I'm not ready to comment on what the average score was this year. Not ready yet. Don't ask me. Not ready to comment yet. Cool. Hi to everyone else. Hi to Riza. Hi anonymous person, Ali. I should say the chat below, if you're joining us for the first time, welcome to the live stream. The chat below is on slido.com/matlive, which is where you can join in with that. You can be anonymous, you can put your name in if you want to, and that's where we're doing that. Okay, when am I going to release the average mark? Someone said. That's going to come out, I think I'll put the first average mark, the kind of MU1 thing for Oxford applicants. I might release in late November after around the sort of shortlisting time when I put the solutions up as well. Yes, Payne's got it. So I do want to talk about Charlie and the averages. So the averages are going to come out. I'll do the first one, which is the average of everyone who took the test. I'll put out, I think, at the same time as the solutions in a couple of weeks. Okay. Would I get 100% on the MAT? I think definitively no, I would not get 100% on the MAT. Right, okay. We want to know your opinion. We want to know your opinion, James, says someone. Was this paper hard? Personal opinion? It's very hard for me to have personal opinions because it's my job to coordinate this test. Personal opinion, I think this test did end up being a little bit harder than some of the recent tests. Okay. It's really hard to distinguish like my personal opinion from like the Oxford University opinion, right? That is my personal opinion. I think this test's tricky. It involves some things that I personally find a little bit tricky. Good, okay. Without discussing the answers, here's a request from somebody else about other maths that they're doing. UK Math Challenge. How did you find it? And Isaac says, hello. Hello. Have the tests been marked? The tests have not all been marked yet. The marking process is underway. Don't think about it. Okay, hang on, I need to set this dashboard. I've got a little dashboard for chat as well. Speed run one of the questions, please. Question 2, I kind of already speed ran them. Do you want to speed run live? We could do the speed run live if you like. I was going to do a vote. And there's some other admissions questions about when you get things. This video is being made to make people cry, says someone in chat. I'm not trying to make anyone cry. If you don't want to hear about the MAT questions for like a big scary test that you did last week, then please don't watch this video. I'm going to talk about the questions. What's worse is I quite like some of the questions. They might have been the worst things that you've ever seen, but I'm going to talk about them fondly, like I like them. And let's do this one now as well. MAT, is it possible to be accepted with a low MAT score, says someone. MAT's one part of the application. It's the main thing we talk about on this show, the Oxford MAT Livestream. It's maybe the most important thing that we look at when we're deciding who to shortlist for maths at Oxford or computer science at Oxford, but we do look about other stuff as well. So this is not the only thing that matters when you're applying for Oxford. We look at the rest of your application too. Okay, chat's going super fast. Good luck. Let's speedrun question 2. That seems like a fun start to the show, doesn't it? Have I got that set up right? So question 2, I wrote this one. This is my first ever long question. Sorry. So we gave you an expression for log. I considered log of 1 plus x, but that's got a slightly weirder first draft. Log of 1 plus x has some expression on the right. Also, log of 1 minus x is a little bit weirder, isn't it? It's got all these minus signs in. We give you this big fact. For any x, mod x less than 1, the size of x being less than 1. And we're reminded throughout this test paper that ln natural log of x is the same as log base e of x. We weren't sure which one people have seen. The questions are like my children, right? We're going to be nice about them, like you would about my children. Okay, so the overall shape of the question, the thing that I've tried to design was to show you how to do a calculation. So here up here, I'm trying to show you how to do a calculation to prove something cool, that logarithm of 2 is between some fractions. We're going to bound it. We're going to say that log 2 is between these fractions. And then in the second half of the question, I kind of take away the training wheels a bit, and I get you to do basically the same calculations. But look down here, we're putting logarithm of a number between some fractions, taking away some of the training wheels and saying, okay, did you understand the previous part? Can you do it again with different numbers? The calculation is also harder in the second part. Right, I am going to do a poll for questions and a poll for how your day's been. Oh, let's do how your day's been. Go on then. I'm going to do a poll, but got distracted by someone asking for question 2 in chat. And, Raf says they left question 2 till last. Okay, let's speed run it. Okay, so if you plug in x equals I think 1/2 for this first part is a good idea because it makes log of 1/2 on the left-hand side. So that's a pretty good start. I'm putting in 1/2. Also on the right, I get all these powers of 1/2. So this would be 1/2, this would be 1/2 squared, 1/2 cubed, 1/2 to the 4. That's exactly what I want, except for all of these minus signs. There are so many minus signs. And also, on the left, I've made log of 1/2 instead of the thing I want, which is log 2. Wait a minute, I know that log of 1/2 is minus log 2. Okay, so I can use that thing to get rid of all the minus signs, and this works out. This is true. Okay, so I think marks probably for plugging in x equals 1/2. We gave you some choices there so you could show off that you chose x equals 1/2 and got it done. And then marks for using a logarithm fact. You get there. Okay. Here's the tricky bit. Okay, so using part 1, we've got this sum now, and the fact that, and then I've given you this fact that 1/n2 to the n is small. It's smaller than 1/3 2 to the n. If n is some big number, right? So this fact looks completely weird and stupid because 1/2 to the n is in both bits of it. Like, how is this even a fact? If I take away the fact, then it just says that fractions get smaller, and you're like, I know that fractions get smaller, James. Why are you telling me that fractions get smaller? I put the 1/2 to the n's in there to make it look like the previous things. Anyway, if you make this replacement for n bigger than or equal to 4, so if you replace this one, this is less than 1/3 times 2 to the 4. This is less than 1/3 times 2 to the 5. If you make that replacement, then all of the stuff from here onwards, so including this one, all of the stuff from here onwards, all of that stuff over there is a geometric progression. I really like a good geometric progression. And add all of that up, and we just get some sort of nice fraction. And there's some mess around with some fractions, and it turns out that log 2 is smaller than 17/24. Log 2 smaller than 17/24. How are people's days going? Oh, we've got quite a few 5-star votes in there, which is nice. And some people doing kind of 3-star days. It's interesting that it's bimodal. And I'm looking out for the kind of 20% of people who voted 1-star or 2-star. Sorry that your day's not going super well. Hopefully you can find something fun to do now or this evening. Oh, SV's got a different approach to 5, and Raf has done a different admissions test that was more, quote, digestible. I'll bear that in mind next time I'm making an admissions test, to make it more digestible. Okay. I suppose we should also check that log 2 is bigger than 16/24. We could go and do clever stuff with exponentials, or we could look at part 1 again. And if you look at part 1, this is a sum that's adding together lots of things that are all positive. And if you just add together the first few terms, I think if you add the first 3 together, you get up to 16/24. Okay, and then there's some more terms afterwards that are all positive. Managed to get the right inequality without using a geometric series. How do I feel about this? Okay, well, that's going to get marked at some point. Cool. Good. Part 3, training wheels off. Here I'd take x to be minus 1/2 is what I had in mind, because I'm trying to make log 3 over 2. Now you could think about trying to make log 2/3 instead, using the flipping trick from part 1, where we made log 1/2 and flipped it to log 2. Here you could try and make log 2/3 and flip it to log 3 over 2. That turns out to be not quite what you want, because log 2/3, if you plug in 1/3, for example, then you get lots of powers of 3, so it doesn't quite match up. Cool. You can do something like that to make a similar expression, and then pair these things together. So log 2 plus log 3 over 2 is log 3. So add these series together. Okay. Last part on the bounds. I think what you need to do to get this upper bound is to do something similar, to replace this. This is smaller than 1 over 5 times 2 to the 6. The next term is 1 over 9 times 2 to the 8. That's less than 1 over 5 times 2 to the 8. So now I'm replacing all the numbers down here with 5s. And I think if you do that, then you end up with a geometric series. Geometric progression that you can sum. And I think that one ends up as 66 over 60. If you do the arithmetic for the geometric progression, add it all up, 66 over 60. That's all right. Can I leak the mark distributions? No, thank you. Getting wrong value of k in part 2. I'm not sure how much I want to go into the marking details. It's kind of what Will said about leaking the mark distribution. I think the kind of technicalities, I think we're going to have to wait for the mark scheme thing. Wrong value of k, what does that actually say? Wrong value of k in part 2, lose marks in part 5 as well. Well, it might make it hard for you to tell which of these numbers is bigger. So yeah, I think it might mean that you can't do the last part if you've got the wrong value of k, because you can't tell which number is bigger. There's a way to do the last part using the facts that you proved along the way. How long have I been muted? Thank you, Flora. Another geometric progression, and then the last part. We just add it up. Thanks, Flora. Audio died. So that's everyone in chat, thank you. You see the 20-second lag? Yep. It's because I pressed a mute button that I didn't know about. Mic's cut, silenced, muted. James, why did you go to Oxford instead of Cambridge? No sound, I can't hear you, muted. 30 seconds. Oh, back up 30 seconds. You know what I said? I drew a geometric progression on the board. And also, it all adds up to 66 over 60. He bound it. Last part. This 17 in the question here is related to the 17 that we found higher up for this bound up here. The parts of the question are kind of related together. Yeah, I'm trying to repeat some of the things I said, but because of the 20-second lag, I'm confused about what I said and what I didn't say. Anyway, there are other approaches for this, involving carefully working out the ratio between these things and bounding. I've seen people approximate 81 is slightly bigger than 80, which is some sort of fact, because 81 is 3 to the power of 4, which is slightly bigger than 80, so then 3 to the 17 is like, aha! There's some method that goes like this. Good. Good. I got an email from Cambridge saying I'm accepted for an interview and James is interviewing me. That's not true. Or it's a different James. Cool, right, okay. That's question 2. The reason I put question 2 in, I've really lost my rhythm with the pause for not talking. I wrote 17 log 3 and then the sound died. That was now about a minute and a half ago, and I'm worried that I'm repeating myself now. Turns out my microphone hates logarithms. The reason I put this in is this idea about bounding things with geometric series, progressions, geometric sums like that, is quite powerful, and I kind of wanted to show you and then get you to do this calculation where you take what you know about geometric progressions, how to sum them, and use it for different sums as well. It turns out to be quite a powerful idea that you can use in other bits of mathematics, and if you do maths at university, which I think a lot of you will, if you do maths at university, then you'll learn a lot about comparing sums to geometric series, just because we can do geometric series. So it's kind of comparison between things to get cool facts about sums. Ooh. What do I think? This was harder than 2019 or harder than 2021? 2019 was really quite hard. I'm allowed to say that now. 2019 was really quite a hard math paper. Right, okay. Which multiple choice questions did I make? Ooh, good question. It's a team effort on multiple choice. I think I proposed the idea for a lot of the multiple choice questions, but it's really like a team effort. They get workshopped quite a bit. We're going to do a vote for what we're doing next. That was a very quick look at question 2, talking a little bit about these factors of 17 and bounding things with geometric sums. So the idea of the question. Payne noticed that Charlie was back. I kind of want to talk about Charlie coming back. People are voting. Here we go. Okay, so the way the vote works, I hope, is that you can vote for multiple options. You can choose your favourites. You can still switch to chat if you want to. I can't do it on the screen, but if you want to switch to chat, then you can do that over there, where people are asking admissions questions. I'm going to do one admissions question now, and I'll take the rest at the end, I think. While we're voting, though, I'll take this one admissions question, which is when are we receiving the results, if we are shortlisted or not. For Oxford, we're doing shortlisting letters at early December or late November. Late November if we really get on with it and we do it very quickly. Early December, at the sort of latest. That's when decisions go out by email. People want to talk about those triangles. Cake's slightly behind. And then question 3, polynomials. The sine squared question is on the screen as well. And computer scientists here, maths and computer scientists voted for questions 6 and 7 as well. I see you. Question 1A. Okay, well, democracy, nice, okay. So let's talk about question 1A. Or are you going just after? Thank you, someone said just after, let's talk about question 1A. Democracy, eh? I want to tell you why question 1A is here. Question 1A is here because it's a proof that pi is bigger than 3, which I thought would be a nice thing to get people to do. So that you draw this 12-sided shape. This is like trying to draw a clock, isn't it? Let's try and do it like a clock. 1, 2, 3, top, bottom. These ones. You draw this 12-sided shape. Squint, is that 12? It's about 12, isn't it? It's not very good, but it's about 12. Cool, we'll take that. You draw this 12-sided shape, 12, and split it into these triangles. If you work out the area of each little triangle, they've got little 30-degree things at the centre, and the areas add up to 3. This is here because the area of the circle is pi, and the dodecagon is 3, and it's smaller. So I thought it'd be nice to have a proof that pi is less than 3 to kick things off, so that whether or not you enjoy this test or not, you've now seen a proof that pi is less than 3. 5:20. That's a 2-minute delay of somebody watching the previous time I was muted. We're good. At least the tech didn't go during something important like question 5, which we're going to do now. Not muted, good. Okay, question 5's got some reading to do at the top. Let's go. Did I say pi is less than 3? Quite possible. Is pi bigger than 3? You see, now I've got distracted and I'm saying nonsense like pi is less than 3. Pi is bigger than 3, gang. Okay. Cool, flustered. Right. Don't take away my microphone, it really ruins me. I need to know that everyone's listening to this. I need to know that people are listening to everything I say. That's always important to me. Right, okay, triangular triples, let's go. 3 numbers in a triple like this, A, B and C. There's an inequality in there, but it's trying to demonstrate that if A is less than or equal to B, less than or equal to C, then all you need to check is that A plus B is bigger than C. And later on we're going to let people sort of assume, without loss of generality, maybe it doesn't matter which order they're in. For some of these facts, it doesn't matter what order they're in. But we are going to count those as different triples. So look here, 3, 5, 4, we're counting as different from 3, 4, 5. And we're counting that different from 4, 3, 5, 4, 5, 3. So we're counting these kind of differently. I guess that first row is kind of all the same thing, but permuted around. So to work out these values at the start, we need to try and find all the possible triangles. For f of 3, we've got a perimeter of 3 to work with, and integers are going to start at, positive integers are going to start at 1, so I guess this is the 1, 1, 1 triangle. So that's 1. There's only one possibility. For f of 4, I guess I could have 4 is equal to 2 plus 1 plus 1. The only way to increase this by 1 is to do 2 plus 1 plus 1. But unfortunately that doesn't make a triangle, that makes a line with just ones in the middle like that. Ones like that, which is just a sort of line. We've been asked that it should make a triangle requiring a plus b actually bigger than c if you line them up. 1 plus 1 is not bigger than 2. 1 plus 1 is equal to 2, as discussed. Okay, right. So that's 0. F of 5, I think we're going to have, how do we make 5? Well, we could have 2 plus 2 plus 1, I suppose. So then my triples would be 2, 2, 1, 2, 1, 2, and 1, 2, 2. Those would be my triples. I think there are 3 possibilities for this because I'm allowed to switch the numbers around. And then f of 6, I think the only possibility now is 2, 2, 2 for a triangle. Okay. Welcome to the Oxford MAT Livestream. 1 plus 1 is 2. And my microphone doesn't always work. Right. Okay. Cool. I think if you get one of these wrong, you're probably going to lose 1 mark. It would be my guess at this stage. Okay. Here's a check. If a plus b plus if ABC is a triangular triple, we're asked to check that adding 1 to each side is still a triangular triple. The thing I would do here is to say, well, if a is less than b, it's less than c. Okay, so if they're lined up like that, I'll come back to the other orders in a minute. But if a is less than b is less than c, like this, less than or equal to, less than or equal to, then I must have a plus b bigger than c. That's what it means to be a triangular triple. For this to be a triangle triple. That's the fact I've got so far. Now, so I know that. Here's what I want. Secretly, I want to show that a plus 1 plus b plus 1 is bigger than c plus 1. Okay. I'm going to work out a plus 1 plus b plus 1. I'm going to write down a true fact, because writing down true facts is good. It's a plus b plus 2, which is, then I suppose using the only fact I've got here is bigger than c plus 2. And I want to say that I wanted this to be c plus 1, but good news, I'm okay. This is bigger than c plus 1, because c plus 2 is bigger than c plus 1. Okay, why did the computer science department get to set question 5? The computer science department very generously helped by coming up with the original idea for question 5. And then we all worked together to work on question 5. So someone here is trying to blame the computer science department for this, but I signed off on this too. This is a maths question used for maths applicants as well. Cool, okay. Right. Okay. And then I think if otherwise, we can do some sort of relabeling. We can rotate it around and it'll still be a triangle. We can rotate the triangle around and it'll still be a triangle triple. Okay. Cool. So there's this sort of weird bit of argument that they've added in. Not sure how important this is. That if the sides are in the order that I want them to be in, then it's fine. I know what inequality to write down. If they're in a slightly different order, then it doesn't actually matter. The letters are the wrong way round for the numbers that you've got, but it still works out. Yeah. Okay. Right. Part 3 has got this weird odd even argument. It says, if x plus y plus z is an even number, we're going to show that you can go backwards. So this kind of forward step said you can add 1 to each side. Now this says you can subtract 1 from each side. There's a little bit of argument to say that you can't have x equals 1, say, because if you have x equals 1, then either if you have y equals z, then the sum is odd. X plus y plus z, and if you have y less than z or y bigger than z, then the difference is at least 1 between y and z. So you can't have a triangle because you can't do the triangle inequality up here. Can't have x plus y bigger than z, sad face. Okay, so you can't have x equals 1, so you must have x equals at least 2. And similarly for y and z, real life Sheldon Cooper. Right, wow, okay. Thanks, chat. It's a great live stream for my self-esteem. Also y and z. There's this check as well to check that you can subtract 1 from each side. That turns out to be pretty similar to the argument that we just did, except sort of backwards. Let's try and make that work. So I want x minus 1 plus y minus 1 bigger than z minus 1. And I have, so I suppose I'm saying maybe x, y and z are in that order. If they're not in that order, change the numbers around and you still get a triangle. You still have a triangle really somewhere that's been rotated and flipped, but you still have a triangle really, but you can say that x is less than y less than z. So I want this, and I have this. Okay, so this is actually quite dangerous because I've started with a true inequality, and the thing I want, I've subtracted 2 from the left and 1 from the right. So there's this danger that the left decreases by 2 and the right decreases by 1, and they end up, well, you can't end up with this being, you can't have x plus y minus 2 less than z minus 1, because x plus y was bigger than z. The integers are quite far apart, so you can't have this be less than z minus 1. But it could be equal. Could be x plus y minus 2 equals z minus 1. This could be equal, you know, if x plus y was only just bigger than z, and then I decreased 2 from the left hand side and 1 on the right hand side, they could end up being equal. But x plus y and z, there's something going on here with the signs. This is like even versus odd. The signs of stuff means that particular case is not quite possible. What do I think of maths? Maths is great. Love maths. Not sure I love this right now. I thought this would be more fun. Save from this trap by my tense brain. Cool. These parts show that those triangles, you can add one to the sides, you can take one away from the sides, the things match up. The number with small sides, number with smaller sides equals number with big sides if you end up at an even number up here. Because we can only do the subtraction step if you started with an even total for your perimeter. Okay. Final part. Final 2 parts. To work out how many of these things there are. Well, I think the average is going to be around about 50, more or less, because it usually is. Cool. Consider the case where p is bigger than 6 is even. I'm going to write it like this. I suppose bigger than 6 is good because we saw when if p is 4, there are no triangular triples. When p is 6, then we can start to get some triangular triples. Right, p is 2 times s. Okay. So we're asked to show that if ABC is a triangle triple, we need to show that each of these is smaller than s. I think s stands for semi-perimeter, but don't expect everyone to know that. Okay. So what do I know? I know that. So let's do this down here. I know that this is true. I'm going to write it in terms of s because the target thing I'm going for is in terms of s. And I know that a plus b is bigger than c if a is less than b is less than c. Cool. If not, then rotate it around and try a different arrangement of the triangle. Again, there's that weirdness about it describes a triangle, doesn't matter what order it's in, you get kind of the same triangle, like the triangle exists. Rotate the letters around until you're describing one with a less than or equal to b less than or equal to c. Okay, so I've got a plus b plus c is 2s, and a plus b is bigger than c. I can sort of see where this is going. Because I've got these things added together to make s, and this says that the a plus b one is bigger than that one. So that one's bigger than that one, they add up to make 2s. So that kind of means that one's got to be, the small one's got to be less than half. If they're both bigger than half, it's bad times. So So the small one's going to end up being less than half, right? Let's try and plug that in. So what can I do? I can't quite plug this in. I suppose I could say a plus b plus c, the sum overall, is bigger than this a plus b bit is bigger than c. This is bigger than 2c. Aha, so that was 2s. Equal to a plus b plus c is bigger than 2c. Aha, so s is bigger than c. Okay, good. Right, brilliant. Same for the other ones. Because I've remembered that if a is whatever order they're in, you can also, this is also true, and this is also true for a triangle triple. These are, perhaps they're not written in the paragraph at the top, but these are also true if this is whether a less than b less than c or not. These are also true for your triangle triple. These ones have got the advantage, they've got the big number c on the left. C is massive, perhaps, if you're in this order. So these are sort of not true in an interesting way. Cool. Good times. Thoughts on women? Pro. Yeah. Good. Right. Okay. Other inequalities. These ones also mean s bigger than a, s bigger than b. Right. Cool. It's an if and only if. So we're supposed to check that if all of these things are true, then we're supposed to check that this is a triangle triple. But that's okay, because if s is bigger than a, then we've got a plus b plus c is bigger than a, over 2 is bigger than a. And we can rearrange that to say that b plus c is bigger than a, and the others. We can get back again. It's reversible. We can get back. Okay. Bye, Leandro. Due to lag. That's, you've already gone. Okay. So this is a little bit weird. This is sort of checking that in a triangle triple, each side is smaller than the semi-perimeter. That kind of actually makes sense, I suppose, if I pause and think about it, which maybe you don't have time to do during an exam. But if one of the sides was bigger than half the perimeter, then the other sides, they're not going to be able to get back again. Triangles have got like one side, and then the other sides, it's like taking the longer route around from A to B. I'm just drawing triangles in the air now. The other two sides are going to be kind of longer, so they've got to use more than half the perimeter. Okay, excuse me, just got a call. Try to work out how to not get a call. Is it urgent? Don't think it's urgent. Cool, right, good. Fun times. Okay, last bits. We've got a 5b. We're asked to show the number of possible values of b that make this work is some particular number, a minus 1. Okay. So here's my plan. We just worked out an inequality. So we know that a is between 2 and s minus 1. We also know that b is between 2 and s minus 1. We showed that b was bigger than 2 ages ago, something about even perimeters. So we also have that 2 is less than b is less than s minus 1. And we also know that 2 is less than c is less than s minus 1. Less than or equal to here. I guess because they're strictly smaller than s. So these are the options for these numbers. I suppose I've got 3 of these conditions, but I also know that a plus b plus c is equal to 2s. So the idea is the slightly mad, perhaps, of going in here and plugging into this one for c. Okay, cool. So I've got some nice expressions that tell me I could think about this one as being some sort of new rule about b in terms of a. In particular, I think it says this. B's got some lower bound. It has to be bigger than s minus a plus 1. I don't have a good intuition for this one. I had that story about triangles taking the long route round, but I don't have one for the other way around. Campaign for James to do 1 interview for each college. Logistically tricky, involves me doing right to work checks for a lot of stuff, a lot of different people. Cool. We've got a lower bound of b. We also still know that b is less than or equal to s minus 1. That gives some range for what b could be. Within there, b could be any of those numbers. So there's some nice range for what b could be. I think that's a minus 1, different things. Last part, actually sum that up. Sum that a plus a minus 1. We've got these options for what a is. Add those up. That was an arithmetic progression. Sum the arithmetic progression. I think this expression turns out to be s minus 1, s minus 2 over 2. I think. So then f of 21 is slightly awkward to work out because this stuff we just did was for even numbers. I think most people missed that. By the time you get to part 6, I think most people missed that the previous part is all about even perimeters. So for this last part, I can't just plug the number in. I've got to use the previous part and say that f of 21 is equal to f of 24. I've got to add 3 to do that trick from before. Adding 3 to it to do f24, and now that's even. So now I am allowed to use the formula we just worked out. Maybe that was too hard for a last part on the end. Flora, are you dropping your socials in chat? We had a briefing on this. What's Flora? Flora doesn't have Instagram and can't share social media with you. Well done, Flora. Because that's from an anonymous person, Flora is going to think that was a test. That wasn't a test, Flora, but you passed. Cool, right. Question 5. Lots of inequalities, loads of stuff going on, lots of integers being not quite. There's something in there like gaps between integers, loads of stuff. Cool. I think I'm not going to do that, but there we go. Is there a timetable for when maths interviews are? Yes, there's a timetable for when maths interviews are on the Oxford website. If you go to ox.ac.uk/interviews, I think there's a provisional timetable there for when they might be. Ooh, a couple of requests. Oh, my word. Flora's approved one to let you know that you're not getting Flora's Instagram. Flora's non-existent Instagram. And you've messaged me to say, don't worry, I think due to chat lag. Right, cool. Can I bring my dog and cat? This is an extension from last week's problem. What we're doing here is exploring possibility space. I think last week somebody said, can I bring my cat to the interview? And I pointed out that interviews are online, so it would perhaps be effort to not bring your cat to the interview. And now there's a dog and a cat, which, to be honest, sounds like quite a lot of animals being involved at this point. Cool, good. And people are very keen on finance chat, which is fun. Which college am I at? Good question, isn't it? I don't normally have a college. I normally don't have a college at all. I'm doing interviews for one college. I'm interviewing for Christchurch this year, and I'm doing some teaching for a new college at some point. Can I invest? Yeah, you're not getting Flora's social media. There we go. Okay, cool. Good. How have you found uni without Instagram? There you go. Ellie's asked a question there. There you go, Flora. How do you find uni without Instagram? We're finding out about stuff. How do you do it? I also don't have Instagram, but I did go to university before it was big, I suppose. Let's do the what's next vote. I like the what's next vote. Talked about triangles a bit. I talked about triangles not very convincingly. Not one of my top 10 questions, I suppose. Oh, that's harsh. There's only 16 of them. Maybe it's my top 10 questions. I don't have a ranking of questions. Let's not pretend I have a ranking of questions. Could do a couple more, I think, before I call it a day. Cake question's doing well. Quite like the cake question. Have I ever been to St John's? Yeah. Quite like the cake question. Oh, X plus IY has dropped by to say hello. Hello, X plus IY. Good. Cool. Somebody wants to know what my favourite question is. Yeah, that's nice, isn't it? What have we not talked about? We've done 2 and 5. Got the most attention, I suppose, because everyone does them. Oh, the cake question's overtaking. Oh, can we talk about cake? Multiple choice question break sounds really good. I actually quite like the multiple choice question break idea. We could do the democracy's coming back, don't worry. It's like partially democracy, partially just me doing stuff that I want to do. Lots of these questions were thought of quite a long time ago. And of course I'm not allowed to talk to people about the questions before then. I've had to do the entire MAT Livestream without talking about these questions. And now I'm actually allowed to talk about them. And I'm not quite sure that people want that. I'm allowed to talk about them now, but I think maybe people don't want me to, which is okay. This one only, talking about the ones that they've done. You're also not having my social media. There we go. Cool. Yeah, multiple choice question break. There we go. That person's won on the multiple choice question. They got their way. This question is about adding together sine squared values, and it looks like an arithmetic progression question. Question G. Raf missed the sine squared 90 at the end. Yeah, so there's sort of a... It's not quite a trap, it's just... There's something that this question is not. It's not an integration question. It looks a little bit like, for people who know about the trapezium rule, it looks a little bit like we're integrating sine squared. So it's possible to get too excited about this. If you know the trapezium rule, then you're like, aha, this is something to do with the integral of sine squared x from 0 up to the 90 degrees, and the integral of sine squared x, well, its average value is 1/2, and that's 45, so I'm going to choose C. And that's not a trap, because I wouldn't set a trap for you like that. It's actually a trapezium that you've fallen for yourself. It's not quite 45. It's related to that integral, which, by the way, the integral of sine squared is not something that I would set on a math question. So be glad that it's not this integral, I suppose, because everyone knows this integral works like that. Not everyone knows how to do this integral. Anyway, so it's not this. What is this question? What is going on? Yeah, it helps if you add in sine squared of 0. If you add in sine squared of 0, somebody said? You've written a previous draft of this question. So you've got this previous draft of this question. You had this, and that adds 0 to it. Maybe that makes it more obvious how to pair up the terms. And I'm saying pair up the terms because there's this way to pair up the first and last terms here. Sine squared 90 is 1, and sine squared 0 is 0. Those are extreme opposites. Those make 1. These ones, sine squared 1 and sine squared 89, sine squared 89 is cos squared of 1 degree, because cos of 90 minus x is sine of x. So these things add up to 1 as well, and they keep going, except don't forget that right in the middle there is a sine squared of 45 degrees. I suppose that's the trap. That if you add in a term, then there are an odd number of terms and they don't pair up. If you don't pair up a term, then if you don't add in a term, then they don't pair up very nicely, but there's an even number of them, so you might think that they do. So this awkwardly hiding in the middle is equal to 1/2, which makes the total sum 45.5. Cool, okay. Which it sort of shouldn't be. It sort of feels like it should be 45, all things balanced nicely, that these things should average out to be 1/2. Slightly bigger, 45.5. So I think this turns out to be I think this might have been one of the hardest multiple choice questions. But it's nice, right? It looks like a thing that I'm losing this audience. It's nice, right? This question that was really hard on a test that you did last week. It's a really hard question that matters to you so much. Why am I doing this? Isn't it nice? No, it was really hard. Right. Regretting my life. Why do I do this? Cool. Right. No, I'm fine. Okay, so cake. That was the break before we do the cake. Cake. The cake involves Charlie trying to cut a cake. I wonder if did people get the gimmick? The first draft of this question had a lot more text at the top to try and explain the gimmick. Charlie is bad at cutting cake. This is not how you're supposed to cut cake, Charlie. Charlie's trying to do... If Charlie was good at cutting cake, then Charlie would go for the middle, like a normal person, cut down here, and then cut left, and take away a quarter of the cake with area 1. That's what Charlie's trying to do, but Charlie's bad at cutting cake. Lots of previous drafts of this had text about how Charlie was bad at stuff, and this was an unintentional thing, but it's kind of confusing having all that stuff. Yeah, don't judge Charlie. Charlie, by the way, is from the logic questions. Last year on the MAT Livestream, we had a bunch of logic questions from past MAT papers involving first Alice, Bob and Charlie, and then there's one without Charlie in. So people in the chat last year asked where Charlie was. There was this question last year. Oh gosh, don't look at that. What is this? I've taken such a bad screenshot here. Hang on a minute. Absolutely clueless. Right. From last year, we had this question on the stream where we had Alice and Bob, and Charlie is writing numbers on their heads. So I drew this on the stream last year, and that kind of inspired Charlie to be in this question, I suppose, holding something that was supposed to be a pen but does look like a knife for cutting cake. So there's the canon, right? There's an extended universe now. This was a knife all along, and now they've found the cake that they want to cut up. Cool. A gimmick is like a small jokey thing, or a small not a serious thing, like a silly thing. So here the silly thing is Charlie's trying to cut the cake but bad at cutting cake. It's not maths, but it's the kind of silly thing that's going on in this question. Right, okay. So trying to cut this corner of the cake off, but here's what happens. You make the first slice and you miss. If you miss the middle of the cake, can you get the rest of the area? Can you make it work out? Can you style it out so that you cut wonky and then you've taken a fair amount of cake? Can you get away with this if you're Charlie? Also, from last year, we don't know what pronouns Charlie uses. Could be he or she or anything else. Which I found out because somebody watching the chat last year was called Charlie. Maybe didn't use the pronouns that you might have guessed. Okay, cool. Groovy. How long am I going to go on for? No idea. Would like to stick around for question 6 or 7. Cool. We'll see what we can do. 10 minutes to 6. Okay, so first part, check that you can work out the area of this bit of cake that Charlie's going for. Show that maybe Charlie can get away with this and make an area slice 1 if they satisfy these inequalities. The region looks like, so to sketch the region, I'm going to sketch y equals 2 over x and also y equals 2 over x minus 2. I'm going to do that tiny for some reason. Power of technology, we can zoom in. 2 over x looks like this. Oh, no, it doesn't. 2 over x looks like this. It comes down to when x is 2, this is 1. When x is 1, this is 2. So that's where that line meets the edge of the cake. And 2 over x minus 2, oh, right, that's 0 when x is 1. And it's 2 when x is something like 1/2, I think. Maybe 1? This is a 1 as well. It's just bad handwriting. Okay, so there's this region over here, which includes the middle, which Charlie was going for, includes the middle of the cake, where Charlie can get away with cutting the cake like this. Okay, that's my region. Second part is if they cut it differently, you use a similar calculation. It's a little bit like question 2 in that we do this calculation the other way. The bit of the question that I thought about asking, which you can have as homework if you like. I'm not sure if people want homework following a test that was quite tough that they did before. What's the area of this region? So this is the region R. What's the area of that region? Now, there's multiple reasons why that's not in the MAT question, but it's kind of cool, right? That tells you, I suppose, the probability. If Charlie makes that first cut kind of at random, picking a point on the cake at random, what's the probability that Charlie can get away with it and cut to somewhere on the left edge of the cake and say, yeah, that's what I meant to do, quarter of the cake, perfect area, nailed it. Pencils, I think, worked out to be okay this year. We put it through the scanners. I think the pencil might have scanned okay this year. I was really worried before, but I think it's okay. Okay. I know lots of people emailed me about pencils. I did say use pen on the front. If you used a pencil, I think it scanned okay. Okay. Good. What am I looking at? So the area is a really fun question. It's not quite a MAT question because these 2 over x curves, you don't know how to integrate those for MAT. You don't know how to integrate 2 over x. It's sort of the 1 power of x that we can't integrate because x to the minus 1, if you add 1 to the power and divide by the new power, you're trying to divide by 0. So I couldn't get you to find that area. except there's a nice geometrical way to find that area, that shaded area there, bounded between these two curves, involving transformations of graphs and stretching and squeezing areas around. So if you're very keen, there's a way to work out that area without doing any integration, to work out what the region of R is. If you don't know what I mean, but you do know integration, then here's the sequence you can try. Do the integration to find the area, and then you'll see what the area is, and then that'll give you a clue for what the geometrical moving things around answer might be. Good, okay. Is it good to know the answer to interview questions beforehand? No, we're going to surprise you with maths questions you haven't seen before. We're going to ask you mathematics things that, like how the MAT has questions in that you didn't know the answers to beforehand. We're going to ask you about maths. Cool. If you have a maths interview, computer science sort of mathematics sort of themed computer sciencey stuff. If you come for a computer science interview, okay. Interview questions next week, which might be a more fun live stream. I think people prefer the ones that are before a thing versus the ones that are after a thing. Okay. Isaac's off. Bye, Isaac. Oh, still going to do the Doctor Who Society. Good. Okay. Counting on you. I should have checked if it was a thing. Okay. I've set homework for a maths club that doesn't want any homework. How's your day going? Right, cool. Let's wrap this up. 5 minutes of Desmos and then 10 minutes of computer science. I think that's how I'm going to wrap it up in that sequence. So if we don't care about computer science, you've got 5 minutes left of MAT Livestream before we talk about interview questions next week. I want to talk about Jay. I want your help with Jay. So Jay sets up these points. Here's where they are. And tells you to make this quadrilateral. And there's loads of algebra to do to work out when it's got all four sides the same length. I saw some pictures, people have drawn these kind of rhombus kind of things over here, which is nice. Maybe think about vectors, think about shapes that are going on. I thought I'd show you this Desmos plot because all the algebra works out fine. You can sort of do that sort of thing. Set all the side lengths equal to each other. There's a bunch of stuff like like the length AB is equal to B minus A squared plus C minus B squared. Let's go for that squared. The squared length is this. There's a bunch of things like this that you want to be equal to each other. So there's sort of all of these conditions, and you could do some difference of two squares stuff and factorize some expressions and think about when these equations are equal to each other. But the shapes you end up with are really special, and I want to show you them now. By the way, so there's some possibilities. As you're setting these sides equal to each other, you can have this condition AB equals BC. That's one condition you could write down. You can write down the condition BC equals CD, and then there are two more, but those turn out to be the same equations as the two you've already got. So people asking about the score to get interviewed, I literally can't tell you because we haven't shortlisted for interview yet. That number's a statistic based on what we did, not a prediction of what we're going. Anyway, never mind. Okay, the picture's actually really nice. Let me show you. Here's a Desmos plot. Cool. I need to move that down a bit, don't I? There we go. Okay, Desmos. So I've loaded this up. So I've got my points. In there, and I can change these sliders to move where the points are. So if I do that, then the points move around. I've got this set so that A plus B minus C minus D is equal to 0. That's one of the possibilities where if that equation down there is true, D equals A plus B minus C, then you end up with not shapes that have all the sides the same length, but you get shapes where pairs of the sides are the same. So you get these nice kite shapes, and you get these nice kind of dart shapes, A, B, C, D, like that, where pairs of the sides are the same length. So that's one of the conditions that you get out. You have to decide, you have to realise that one's not good enough. That one doesn't give you what you want. There's another one that you need to reject that does something similar, but then the right combination is this, where you end up with something like this, which has both of the pairs. So it has the first side the same length as the second side, and the second side the same length as the third side. When you do that, amazingly, and I don't know why. This turns out to be a square. As well as having all four sides the same length, all the angles are right angles. I mean, I sort of know why. I could do the algebra for why, but I don't have a good reason for why this is a square. As you change the numbers, you can move the square around, you can change where it is. It's like that thing in 2020 where there was a square and an angle. Let's try and make that one. Square and an angle, and it really annoyed everyone. There we go. But it has to be a square. If I told you it was a square in the question's a little bit easier because you know it's got right angles in. Here it sort of turns out nicely that having all four sides the same, in this particular case, is the same thing as being a square. Cool, right, okay. I'm really sad and cannot focus on my interview preparation. Right, okay, and I'm panicking because what if it's about the MAT Livestream? No, it's because England lost against New Zealand. Sorry. Yeah, silence. Eliminate 3. Ooh, marvellous. Also, hi. Okay. So I guess my kind of question on this is, what is this? What is this? We've got 4 numbers and we're doing this weird A, B, B, C, C, D, D, A thing. What's going on? What is this? Is it some sort of weird matrix transformation? Is it some vector thing? Is it something to do with permutations and rotations? It feels a little bit rotation-y. As I change some of those slides, it sort of rotates around. Feels like it could be a rotation thing, but I haven't quite worked out how it works. So there's a puzzle still to solve here, I think. This question is hard, that's why it's 1J. Cool. Do I think this paper was harder than 2019? I think no. I don't think it was harder than 2019. 2019 was very hard. This is not a terribly question. What is this? Yeah, okay. So what is this question? It's like something that I'm still not sure what this is, right? With permuting letters. And if you want something else to play around with, what happens if you have 3 letters or 5 letters? Can you do something similar with triangles and pentagons? I don't know. I haven't played around with it. Is it the same number of interviews each year? Is number of interviews? Yeah, we do about the same number of interviews every single year. Yeah. Cool. Okay. Oh my word. Z1 plus Z3. Are those complex numbers? Chat, are those complex numbers? Have you put complex numbers into my math question? We talked about this, chat. There's Z's and I'm worried that you're thinking about complex numbers already. Okay, cool. Cool, we're going to do a quick break for some admissions questions that I've missed. And then we'll come back and do questions 6 and 7 really quickly, just have a quick look at some computer science stuff together. What have I missed? How do you look at contextual information when giving offers? It's a question I just saw just now. So when we're giving offers, we can decide to make offers on a lot of different criteria. We've got a project called Opportunity Oxford, which is a sort of bridging program to give people a little bit of extra support if we think they need that based on contextual information. But yeah, we look at it and we sometimes decide to make people offers based on the context around what they've done. Okay, you put the homework answers on the further reading. Oh, it's the classic Maths Club, the Maths Club thing. Maths Club used to have, it's been starred. Can I put the homework answers in the further reading? I'm not sure we have further reading for this, do we? We have a kind of solutions doc for the previous ones. Maybe I'll write up the solution for that, or maybe I'll leave it as one of my mysterious questions that never comes back again. Fraser, overseas interviews may start 6th of December. Yes, okay. With week beginning 6th of December. If I'm applying outside the UK as a UK citizen, that doesn't include me, right? It's about time zones. It's about time zones and scheduling. It's not about fee status. So maybe. We put some of the ones where the time zone doesn't quite line up with time zones normally that Oxford tutors are normally on. We put in the week before, but not all of them. So hard to say. We'll find out when we do the timetabling after the shortlisting. We've got a lot of admin steps still to go. Okay. Are there any Eton boys here? I don't know. Right, cool. Okay. hard to know which way around that request is, really. Okay, good admissions chats. Let's have a quick look. Oh, we're talking about contextual reasons now. Sean's math score is not the best, but there may be some contextual reasons behind it. Will they get a chance for interview? Yeah, we do these bar charts at the end of the round to show how we do shortlist people with lower math scores if there are good reasons. And contextual information is important at that stage. So we look at contextual information not just when we're making offers, but also at the shortlisting stage throughout the process. We're interested in the context. Can I tell you the interview questions we're going to discuss next week so that we can try them before the live stream? So what I was imagining for the interview one is that it's surprise questions. Like in an interview, you don't get to look at the questions beforehand usually. Like that person asked before, can I see the questions before? No, surprise. We're going to do some interview questions that I think I've used before. I think that's the plan. I'm going to do some interview questions that I've used before. But we're going to go through them without studying them beforehand, I guess. Oh my word, do I have the live stream for you? Hey dog, which I wouldn't mind if every chat comment started hey dog. Please don't do that. Please don't do that on every chat message, right? Okay. Hey dog, can we get a stream about interview, i.e. tips and previous questions? That's exactly my plan for this time next week. If you come back here, 5 o'clock on the 18th of November, same channel. That's the plan for next week's live stream. What timing? Cool. I think I'm going to talk about computer science. I think we're not talking about. Let's have a quick look at what we're not talking about. I had a box for that one. Quick look at how we're not talking about this integral, or these tangents, or these tangents, or these probabilistic vectors. There's sort of a gimmick in this question too, but it's probably best not to say what it is. And this sequence of numbers, which has got a name, but we'll work that out at some point, I suppose. I think I'm going to talk about the computer science questions. Okay, let's keep that one there. I love these questions. Do you eat burritos, and how often do you do this activity? Yeah, there's a choice in Oxford, several places. It's controversial which one is best. There's a new one's opened recently, so tricky. I'm not sure what my burrito frequency is. Varies over time, I suppose, depending on how close to a burrito place I live. Okay, question 6 and 7, computer science. And people, I guess I can't really ask you to be nice. We did make you do this test. Yeah, so stats and mechanics. Somebody's noticed there's no stats or mechanics on math. There's a syllabus for this. We've got a one-page syllabus of maths. It's because we don't know if people have learnt stats and mechanics stuff. We've got really basic probability, but in terms of counting problems or stuff, a vector question I just skipped. But we don't think that everyone's learnt mechanics and statistics at the same rate, in the same order as everyone else. So we don't have it on the map. If you want to see some tricky statistics and mechanics questions, have a look at STEP questions, where they've got a stats and mechanics section at the end. STEP's taken at the end of school, end of the last school year, so by that point people have learnt some stuff, I guess. Okay, which one are we doing? You'd be Nikola Tesla to solve computer science questions. Okay, we got some Boolean functions. What are we doing? We got some Boolean functions, and we got some sorted tables. I sort of don't know how much more I want to go into detail on them. We did them very quickly in the 10-minute video last week. Okay, computer scientists, you got 10 minutes of this now. What are we doing? We're not doing all of question 6 and question 7 in 10 minutes. I'm going to go at 1:15. What are we doing? Let me know. Cool. I'm going to start blocking that, I think. Cool. What's going on? Might just sort some tables. Do you want to watch me sort some tables? I don't want to sort the tables. We've got these tables to sort, and then we're going to prove that they're sorted after doing some operations. Or do you want me to talk about 7? Nobody's chat. Thanks for doing CS. So someone. Not clear what I'm doing. Here we go. Chat lag. There we go. Chat lag means that you've now had to sit through 30 seconds with me mumbling while we wait to work out what's going on. 7? That's 2 votes for 7. Do I think these are hard? Right, okay, so full disclosure, I'm not a computer scientist. I didn't study computer science at university. This is not a skill set that I've been practicing. Let's go with that. Gonna flip some physical tables. Question 7, another vote for question 7. How impressive is it to do an Olympiad? Also going to ask you to do the maths if you apply for Oxford. Right, okay, cool. Question 7. Loads of reading, again. Oh, and I've missed the next page off. Whoops. Might try and find that. So, we've got this function, and it's got all these different arguments going on. So it's like the maximum of these things, it's looking at the minimum of these things. Flip means 1 minus x1. The numbers that you put in are all either 0 or 1, and the output's either 0 or 1, is the concept of the question. So this function outputs 1, and when it outputs 0. So I think it turns out that if all of the things are the same, then the maximum and the minimum are equal to each other, if all the things are the same. So flip of the minimum is always going to be different from the maximum. If these things are different, then in some order they're 0 and 1, the minimum is 0. Gosh, so this outputs 0 when all different. And you can also check that if they're not all different, if there's one of each, then the max is 1, the min is 0, flip of that is 1. So you get 1 and 1, minimum of 1, 1 is 1. Oh my word. Cool, okay. So it's exactly this, when they're all different. No, not all the same. Those are not quite the same thing, are they? They can't all be different because there's 3 of them. Phrasing is tricky, isn't it? Okay, big chunk of this question introduces the idea of a majority function, which is a bit like voting. It gets the inputs, and if more than half of them agree that the value should be 1, then it activates and it takes the value 1. It's a little bit like in AI, in neural nets and things. You have these things where you have an input signal, and you want your input, and you want this thing to sort of switch on, to sort of activate. This is like your output. So at some point this suddenly starts sort of activating. Maybe this is like a neuron firing or something that as you increase your input, it suddenly switches on. Here it looks at all of these inputs, and when strictly more than half of them are 1, it switches from being 0 to 1. Yeah, James, just try to guess how many marks are in parts 2 to 5. I know how many marks are in parts 2 to 5, I'm just not saying. Sorry. Okay, cool. So I should maybe say why I'm not saying. No, I think I'm not going to say why I'm not saying. We're not ready to announce it yet. It's because I released the solutions after all of the markings happened, and the solutions are what's got the mark breakdown on. So I don't want to give away what the mark breakdown is before we release it in the solutions doc for everyone. Cool, right. Trying not to leak information. Like one of my main things, I suppose. Okay, so we've got some votes going on here. Like, are these things going to activate and be 1? For this one to activate, this would need both x1 and x2 to be 1. And this would, so needing both of x1 and x2 to be 1, that's the same thing as minimum of x1, x2. The majority of these 3 things, this needs at least 2. Now, my way of doing this, I suppose, is to say, if at least 2 are 1, then one of the following things, at least one of the following things is going to fire, is going to trigger. I'm going to look at min x1, x2. You see, that's 1 if both of them, so that needs both of them to pass. Or maybe I could look at min x2, x3. I'll look at those. If both of those are 1, min will give me 1. That's what I'm testing for. I want 2 things to be 1. And I also look at min of x1, x3. So I look at all the possible pairs. I say, right, okay, I've got these 3 things. One of these is going to be 1. I don't know which one, but if two of my inputs are 1, and one of these things is going to fire off and be 1. So what do I want? I would take the maximum value of all of this. So that as soon as one of them fires, max lights up and says, aha, one of these is 1, so I want to take one of these to be 1. There are loads of other expressions, loads of other ways to mark, loads of other ways to write this, other stuff going on. Okay. Cool. Okay. Hands off bite. I don't actually have kids. I just describe the questions as being like my kids. Right. Cool. Part 3 is about sticking together majority functions. We've got 3 minutes to go. Sticking together majority functions to build other functions. I suppose to really get into this question, it's this fact that there are exactly 16 distinct Boolean functions. There's not that many distinct Boolean functions. There's lots of things that you can write down by plugging together majority functions into each other. But there's only 16 actual functions that you can make in terms of what the outputs are, given the inputs. Why is it 16? Well, so if you've got 2 input variables, there are 4 possible inputs. Because that's 2 squared. Yeah, each one could be 1 or 0. And there are, well, so for each of those inputs, you've got to decide whether to give a 0 or a 1. So for each, you can be 0 or 1, and your function doesn't have to follow, like, there are kind of no rules overall. Holistically, there are no rules overall, so we can have 2 to the 4 choices overall. It's sort of 2 to the 2 to the input numbers. Yeah, 2 to the 4, and 4 is 2 to the 2. If you've got n input variables, then it's 2 to the power of 2 to the n. It's like huge, the number of functions that you can do. Not in the question. Weird. Right. Let's go no. Okay. Actually building some of these 16 functions is a little bit tricky. A key idea, I suppose, is that some of the functions are quite strange. For example, there's a function that always says 0. The always 0 function. Maybe that doesn't sound like it should count. Maybe the always 1 function would be something you're happier with. You can build those using majority functions. The always 0 function and the always 1 function, they do count as functions with 2 input variables. It's like almost a joke function, right? It sort of says your function of x1, x2 is just ignore both of them and write down 0. It's got 2 input variables. It doesn't do anything with the input variables, but it does return a number, so that's a function. Sort of maybe strange that counts as a function. Also, there's the always 1 function. You can write those using majority functions. I'm not going to do it now. It's not actually that hard once you've had the idea of doing it. Once you realise you can sort of hack things together, and it doesn't have to be very pretty. Okay. There are things you can't do though, because there are some very strange Boolean functions in this set of just 16 things. There are some ones that I'll describe as a bit strange. Things like flip of x1. So ignore x2 and flip x1 is not possible. Flip of x2 is also not possible. There's ones where if you say this is 0, this is 1, this is 0, this is 0, which is sort of even weirder than flip. So specifying these values. You can't make that with majority functions. They've got this property that they tend to be, they're more likely to be 1 the more 1s you give them as inputs. So if you increase an input from 0 to 1 for a combination of majority functions, then the output is more likely to be 1. Cool. Okay. There's a last part of this question about replacing the x's with z, where z is the minimum of each 2. And the idea is to consider the different cases for how many of them are 1. So if you download the question from the website and think about how many of these could be 1. What happens when none of the xi are 1? What happens when all of the xi are 1? What about in between 1 or 2 or 3 of the xi could be 1? Think about the number of inputs. Helps you through that last part of the question. Disheartening, says Zizo. Try and study for a test and then basically completely flop it. Yeah, I know. Sorry, this has been a bit of a downer live stream. It's been less of the fun times than we've had in the last, what has it been, 13 weeks or something? 14. But I hope it's been helpful a little bit, or maybe cathartic, or just seeing other people's reactions to stuff as well. Questions are a bit tough. Okay, right, cool. I think I'm going to wrap up the live stream here. Some people have got questions in mod queue, still in the mod queue, and some people have got starter questions that I need to come back to. And I do need to spend the rest of the week getting around to coordinating marking the rest of these. So thank you very much for watching. Next time we're going to be live at 5 for interview questions. So if you're back then we'll talk about some interview questions together, surprise questions. Your homework, if you choose to accept it, is to think about this area from question 4 and to try and work out how big it is, either using integration or geometry methods or both. And I'll see you next week for a, I hope, slightly more enthusiastic and new math stuff kind of live stream. Bye everyone.